Welcome everyone. In this video, we'll take a look at two A-level chemistry exam questions, both 3 marks. We'll cover 2 reactions associated with alcohols and the products that are formed. We'll also look at different types of isomerism, structural and stereo, including EZ. Here are the questions that we'll go through, details are in the description. Let's get started. Alcohols undergo elimination reactions with concentrated sulfuric acid to form alkenes. Water is eliminated. If we draw the reactant molecule out, we can get a better idea of where the water can be eliminated from. A carbon-carbon double bond can form in position 1. We can see that there are 4 consecutive carbon atoms in the alkene product. The name of this product is but-1-ene. Alternatively, a carbon-carbon double bond can form in position 2. The name of this product is but-2-ene. But-2-ene exhibits EZ isomerism, a type of stereoisomerism. Stick around until the end of the video for definitions of isomerism with examples. EZ isomerism occurs due to the restricted rotation around the carbon-carbon double bond. Each carbon atom in the carbon-carbon double bond is attached to 2 different atoms or groups. The structures of the E and Z isomers are shown here. To work out which one of these is the E isomer and which is the Z isomer, Cahn-Ingold-Prelog rules are used to assign priority groups. Priorities are based on proton numbers. Let's look at the molecule on the left first of all. The carbon atom in the double bond on the left is attached to a CH3 group and the hydrogen atom. The first atom in the CH3 group is a carbon atom which has a proton number of 6. The hydrogen atom has a proton number of 1. 6 beats 1, and so the priority group is circled. We can assign priority groups in the same way to the carbon atom in the double bond on the right. We can see that both of the priority groups, which are circled, are on the same side. This molecule is the Z isomer. Using exactly the same process for the molecule on the right, the priority groups are on opposite sides of the carbon-carbon double bond, so this is the E isomer. Post in the comments if you know what the E and Z stand for in EZ isomerism and what these words mean. We have now correctly identified the structures for the 3 isomers and given the correct names. The question asks us to give the skeletal formula for each of the 3 isomeric alkenes. When using skeletal formulae, lines represent covalent bonds, double lines represent double bonds. Carbon makes 4 bonds. If it looks as though carbon is making fewer than 4 bonds, we assume that the missing bonds are carbon to hydrogen bonds. The skeletal formulae and names for each of the 3 isomeric alkenes are given in blue. This question is complete. Here's the next question. This is not a common synthesis, and you should note that most students who sat this paper would not have known the product given this reactant. Paper 3 is designed for students to apply their knowledge. There are clues in the question that will help you to solve this problem. From the molecular formula, the byproduct must contain a double bond. We can also work out that from the previous question, the byproduct is not an alkene. You should be aware that secondary alcohols can be oxidized to ketones. We would use an oxidizing agent such as acidified potassium dichromate if the ketone is the intended product. However, a small amount of the ketone will form a byproduct without potassium dichromate. The structure of the ketone byproduct is shown in red on the right hand side. This is butanone. Sulfuric acid is behaving as an oxidizing agent in this reaction. To answer the final part of this question, we need to name the method that can be used to separate the products. The organic liquid products have different boiling points due to differences in the strength of the intermolecular forces. The most common method used to separate a mixture of organic liquids is distillation, and there's a diagram on the left hand side there to jog your memory. Don't forget you could be asked to draw a labelled diagram of distillation apparatus in your exams. The answers to this question are summarised here. As promised, here are the definitions associated with isomerism. Isomers are molecules with the same molecular formula but a different arrangement of atoms in space. The table shows the name, skeletal formulae, structural formulae and molecular formulae for the alkenes in the previous part of this video. Each of these alkenes has the same molecular formula. Each of these 3 molecules are isomers of each other. Structural isomers are molecules with the same molecular formula, different structural formula and a different arrangement of atoms in space. But-1-ene is a structural isomer of both E-but-2-ene and Z-but-2-ene. We can be more specific and say that but-1-ene is a position isomer of but-2-ene because the carbon-carbon double bond is in a different position. Stereoisomers are molecules with the same molecular formula, same structural formula, but a different arrangement of atoms in space. But-1-ene is not a stereoisomer of E-but-2-ene or Z-but-2-ene. But-1-ene has a different structural formula to both of these isomers. E-but-2-ene is a stereoisomer of Z-but-2-ene. Both E-but-2-ene and Z-but-2-ene have the structural formula CH3CH CH CH3. If that's helped, watch this next video and subscribe for more chemistry explanations. Any questions or topic requests, just post in the comments. Good luck with your studies.